Hi everyone. In this video we're going to be talking about the slope intercept form of the equation of a line. Our learning targets, and there's a few of them, are we can write equations in slope intercept form given the slope and the y-intercept. We're going to be able to graph a line when given the slope intercept form. And we're also going to be able to answer questions about word situations when we're given the slope intercept form of a line. We've sort of seen the slope-intercept form in some of our previous videos. The official form is y equals mx plus b, and you've seen it as y equals b plus mx. Okay, and both those forms are okay. We can change the order there, and it won't affect the outcome of what we're doing. And when we talked about b before, we talked about b being the starting point, okay, of our graph, or the initial point. I think from this point forward, it's probably better to think of b as the point where the line that you're making crosses the y-axis. That's where the coordinate is equal to 0. I'm going to draw a little graph up here at the top for you. All right, so if those are my axes, the one that goes up and down is y, and the one that goes left to right is x. And if I drew a line that crossed both of those there, okay, intercept, if you think of it in terms of sports, football or basketball, is when somebody stops the ball from getting where it's going. Well, in mathematics, the intercept is the place where a line cuts another line at a certain point. Okay, and in this case, the y-axis is being cut by our line right there, that nice big green dot. Okay, so your b in this case, our b in our equation, actually represents the point where our line is cutting that y-axis. And it's usually a good place to start graphing, and you'll see that in some of the examples moving forward. The slope we talked about a lot in the last video, okay, and we're going to continue to use those two ideas, slope equals rise over run, okay, or if you're given 2 points, you can actually calculate your slope as y2 minus y1 over x2 minus x1. All right, but slope remains the same, and remember, it's always the number that's attached to the x term. It's always the one right in front of that x. So let's look at a couple examples. The first example here says write the equation of the line with a slope of 3/2 and a y-intercept of 0, 3. I'm going to write our equation down below here. So y equals mx plus b. Our m, again, is our slope, so I'm just going to put this here as a note for ourselves. B is our y-intercept. Okay, and then the b portion of this isn't the whole entire coordinate. It's actually just the y coordinate here, the y portion. And then all I need to do to make my equation is write y is equal to, and wherever I see m, I substitute the m value there, so 3/2 x, and then my y-intercept is 0, 3, so I would just put plus 3, right? That's a positive 3. So my answer there is just y equals 3/2 x plus 3. For example number 2, it's the same thing. We're given a slope, we're given a y-intercept. Again, I'm going to write my equation just to remind ourselves. Y equals mx plus b. The slope here, the m value is 1. The b value in this case, remember it's the y portion, is just -1. So when I substitute those into my equation down here, I get y equals 1x, and then instead of putting plus a -1, I'm just going to put -1. Remember, you can do that. Adding a negative is the same as subtracting. So my answer here would be y is equal to 1x minus 1. And when you have a 1 in front of the x, you can leave that off. So you could also write y is equal to x minus 1, and both of those would be correct. Let's take a look at another example here. This one actually gives us a graph, and it asks us to graph the line with the equation y equals -5x plus 4. Okay, so again, I'm going to identify the different parts here. My m is this -5. And my 4 here is positive 4. Remember, think of it as a positive 4. And now what I need to do is I need to come down to my coordinate plane here, and I need to start by graphing my y-intercept. So it's the point where x is equal to 0, so I'll start right in the middle. And my y is a positive 4, so I go up 4. And I'm going to make my dot nice and big so it's easy to see. So 0, 4. And now what I need to do is I need to find another point. And I can do that using the slope that I have here of -5. And remember, slope, again, is rise over run. All right, that's the change in y over the change in x. Think of it that way. So in our case, our slope is -5. And if I wanted to make that a fraction, I can make that -5 divided by 1. So to find my next point, I would go down 5 in the y direction. And then I would go 1 to the right in the x direction here. And when you do that in GMN, it'll give you your line for you automatically. Here, I'm just going to draw this manually. But that's what it would look like. And remember from our previous units, this is a negative slope, so it matches the slope, the idea of the slope here, that it's negative in the equation that we were given. Number 4, another example of graphing. So we have our graph. We're given our equation, y equals 3x minus 5. All right, so my slope here is 3. That's a positive 3. My y-intercept's -5 in this case. So I'm going to start by graphing my y-intercept. All right, so I start at 0 for my x, right in the middle. I go down 5. Okay, that would be this blue line down here. And again, I'm going to make this point nice and big so we can see it. And then in this case, my rise over run, that's my slope, is equal to 3. And again, I can make that a fraction by just putting a 1 underneath it, right? So my y, my change in y is on top, and my change in x is on the bottom. So to find my next point, in this case, I want to go up in the y direction. I want to go up 3. So 1, 2, 3. And then I go to the right 1. There we go. And again, I'm going to try to make that look as realistic as possible. On GMM, it'll fill it in for you automatically. And all you need is 2 points to graph a line. Let's look at the word problem we have down here. So this is a multi-part problem. This is something you might see in GMM. Okay, so Farmer Jespel started without any lerts on her farm. Every day she bought 6 more of them. Write an equation for total lerts y. Okay, so the lerts are our y in this case. And x days. All right, so x are our days. So Farmer Jespel started without any lerts on her farm. All right, so at 0 days, we know that she has 0. So that would be our b. b is equal to 0. And m, that's our rate of change. It says every day she bought 6 more, so we're adding 6, so that would be a positive 6. So our equation here would be y is equal to 0 plus 6x. Okay, and you could also say y is equal to just 6x. That 0 doesn't make a difference in our equation. And both of those forms would be correct. The next part here, it says how many days will it take for her to have 12 lerts? Well, this is a good situation where we can go over to our calculator and enter it in and pull up the table. So I'm going to type 0 plus 6x. I'm going to go to my table. Okay, and then it says how many days. In this case, days is our x, so we know that 12, we know that our 12 is our y here. So 12 is our y value. So if I go back to my calculator, I need to look and see where we have 12. In this case, it's when x is equal to 2. So that would be our answer. The answer would be 2. And then the next one says, how many lerts will she have after 8 days? And again, days is our x, so I'm going to go back to my calculator and I'm going to find 8 in my x column. And then how many lerts does she have after 8 days? That would be the number in my y column. That would be 48. And we can think about these last two answers, these 2 and 12. Okay, this is like a coordinate, right? 2, 12, 2 comma 12. And then the next part here, we have 8 days and 48 lerts. So x comma y, 8 comma 48. We can think of both of those as coordinates that the line will pass through. So the next part of this problem asks us to graph it. And remember, in GMM, you're going to want to graph it as array because we're starting at 0 and it's staying positive, right? Because this is the first quadrant. So everything is positive here. So you want to choose array. GMM is going to want to see our starting point here because it is array. Okay, and that's simply where x is equal to 0. And when x is equal to 0, y is equal to 0. So I'm going to put my first point on the graph right down here, 0, 0. And then you can choose either one of these other 2 points that you want. Instead of actually using the rate of change here and going up 6 and to the right 1, I can just use one of the coordinates that I've already calculated. So I'm going to use 8 and 48 because that's to the right a little more in my graph. And again, the further right you go, the further away from that y-axis, the more accurate your line is going to be when you connect those points. So I go to the right 8, and then I go up to 48. All right, so that's right below the 50 line. There we go. And then I'm going to connect my points. So your line should look something like that. And remember, in GMM, you're also going to want to make sure that you choose the correct units, right? So y is our y, or lerts is on our y-axis, so that goes there. And then days is on our x-axis, so that goes down here. And if you need to choose a different scale in the y direction, if your points don't fit, you would do that at that point too. The last problem here, number 6, says write the equation in slope-intercept form for the line shown in the graph below. So in this case, we're given a graph, and they ask us to figure out what the equation of the line is based on the graph that we're given. So the first thing I'm going to look for is I'm going to say, where does this intercept with the y-axis? And you can follow your line down, and where it crosses the y-axis, again, that's your y, that's your x. Looks like it crosses right here at -2. Okay, so I know my b value is equal to -2. And then I also want to figure out my slope, right? Because our equation is y equals mx plus b. I know my b value, but I still need to find my m value to complete the equation here. And we can do that just like we did in the last video. We can calculate the rise over the run. So rise over run, right? That would be our change in y. So it would be this. That's our rise. And it goes from -2, 1, 2, 3. It goes up 4, so it's positive. And then when we go in the x direction, right, that's our run. And it goes 1, 2, 3 in the x direction. So 4 divided by 3. You can put that into your calculator. If you were able to simplify that, you should simplify it there. In this case, it is already simplified. So our slope is just equal to 4/3. So now all we need to do is plug that back into our equation. So we have y is equal to our m, which is 4/3, x, and then plus our b value. In this case, it's negative value, so I can just put -2. Alright, so hopefully that makes sense. There's a few different ways that you're going to see the slope-intercept form applied. You're going to get equations for the lines and be asked to graph them. You might be asked where certain points are based on information that you're given, like we did in the last problem. And you might also be asked to write the equation of the line based on a graph that you're given. Okay, so hopefully that's helpful. If you have any questions, feel free to ask. Alrighty, thanks.